properties of matter. So properties of matter are basically like characteristics. By observing them and measuring them, we're able to use them to help us describe matter in different ways. And we can basically look at properties as physical or chemical. And so you understanding the difference between those is really, really, really critical. So first we're going to talk through physical properties. These are properties that can be observed directly or measured without changing the chemical identity of a substance. So these would be things like measuring the mass of an object, or its volume, or observing its shape, or its size, or the color it is, or the luster. How shiny is it? How hard is it? These are all things that I can measure about an object, about a piece of matter, without actually changing what that piece of matter is. There's a couple that I want to highlight that you may not know about that are important to know. One of those being melting point. This is a physical property that matter has. It's the temperature at which a solid will become a liquid. So we can observe the temperature at which ice melts to liquid water, and that would be a way of describing water physically as a substance. Also, boiling point. This would be the temperature at which a liquid becomes a gas. Another one you may not know about is viscosity. This is a fluid's resistance to flow. So it's a physical property we see only in liquids, and it actually changes with temperature. So usually the higher the temperature, the less the resistance to flow, the better that the object will flow. So it'll have a lower viscosity. I always remember this as how thick is this substance. So for example, syrup is very high viscosity. If you have a spoonful of syrup and you tip that spoon to try to like pour it out, it'll just slowly kind of drip out. Syrup or honey or molasses, something like that. Whereas water has a really low viscosity. It flows really easily. Another physical property you may not know about is solubility, and this is one that's going to be really important, especially for my honor students, because we're going to have a whole extra concept for you about this. But it is a measure of how well a solute dissolves in a solvent. So what am I talking about? A solute is what gets dissolved. Think like lemonade powder. A solvent is what does the dissolving. That would be something like water. And a solution is the result. So we're talking about all these words in relation to solutions, which you hopefully remember are the same as homogeneous mixtures. So that could be like lemonade. So a solute is just what's being dissolved, like the powder. The solvents, what's doing the dissolving, like water. Solution would be, what does that result in? It would result in lemonade. So solubility is going to tell us how well is it at dissolving, because certain things don't dissolve well, other things do. Again, we're going to spend way more time on this with my honor students. One more that is just super critical that I want you to know is density. This is a measure of compactness or consistency of a material. And for those of you that have loved all the math we did in the physics portion of this class, here's your last equation from me. So density can be measured. It's mass per unit of volume. And the units we use for it are either grams per centimeter cubed or grams per milliliter. What I think is super interesting about density is that it doesn't change regardless of the size. So for instance, water has a density of 1 gram per milliliter. It's about 1. It's like 0.998 or something like that. But it's about 1 gram per milliliter. So it doesn't matter if you have 100 tons of water or you just have a cup of water. That water has the same density. So it's kind of cool because we can use density to identify unknown substances if we know the density of a bunch of different materials. So we can calculate it as mass divided by volume. Remember, mass needs to be measured in grams, so we're usually going to find it just by using a digital scale to measure it. And then volume is either measured in milliliters or centimeters cubed. And we can find volume two different ways. So I'm going to show you those two ways now. First is finding volume by just calculating, or calculating the volume in order to find our density. And so that would be if we have an object that is a solid and if it's a regular shape. We would use a ruler and we would use an appropriate geometric equation. So maybe you remember from geometry class, you can calculate the volume of a cube or a rectangular prism by finding the length times the width times the height. So in a cube, those would all be the same, like 3 times 3 times 3. But in a rectangular prism, it could be 2 times 4 times 3. So the length times the width times the height is what we're looking at. Maybe you're finding the volume of a cylinder type object like we have pictured here. You would do pi r squared h. So pi times the radius squared times the height. So these are a couple of the ones that we're going to use in our class. We're not going to look at any other regularly shaped objects, so we'll just be using these two equations. But whichever you would use, you would end up with a unit that's in centimeters squared that you could then plug in into the density equation to find density. And we're going to be practicing with both of these. So let's do an example of what I'm talking about. I could ask you, what is the density of a 15-gram box measuring 10 centimeters by 5 centimeters by 2 centimeters? So we're looking for density, and you know that the mass is 15 grams. We don't know the volume, but we know that we need to find it because density is mass divided by volume. Now this is a box, and so we can see that it's a rectangular prism. So we're given the three sides, the length times the width times the height. So we can use that to find the volume of this box. And that's what we're going to do first. So 10 times 5 times 2, that gives us a volume of 100 centimeters cubed. Then we can plug in to find our density. So my mass is 15 divided by my volume, which is 100, and you would find that the box has a density of 0.15 grams per centimeter cubed. Now, sometimes the objects that we're working with are not a regular shape. They're not a cube or a cylinder that we have this nice geometric equation for. Sometimes they're in an irregular shape, or maybe they're not even a solid. Maybe they're a liquid. We're going to find volume a different way to calculate density. And we're going to do that using something called water displacement. So this is if a liquid or an irregularly shaped solid, we need the volume of them, we would use a graduated cylinder in water displacement. And this would be measured in milliliters would be our unit. So for that water displacement, what I would do is I would put water in the graduated cylinder, enough to cover the object. I would record how much water I put in. So maybe I put in 30 milliliters of water. Then I would add the object to the graduated cylinder, and I would record the final volume with the object in it. So maybe I start with 30 milliliters of water, but then when I add my object, like a pencil, it raises to 40 milliliters. What I can do is I can subtract the final velocity minus the initial, and that'll tell me the volume of just the object. So if I ended it with 40 milliliters and I started with 30, then my object, my pencil, would have a volume of 10 milliliters. And this is something we're going to practice in class. We're going to do this. So don't be worried about practicing this. We will practice. But let's do a written example of this, because you may have one that's written. Let's say a sample of aluminum is put into 10.5 milliliters of water. If the water rises to 13.5 milliliters when the aluminum is added, what is the density of the aluminum if it has a mass of 8.1 grams? So I'm looking for density. It has a mass of 8.1 grams, and we don't know volume, but we know that we need volume to find density. We can't do length times width times height or anything like that because we don't know the shape of this aluminum. But we are able, to do water displacement. And remember, water displacement, we're finding the volume by doing the final minus the initial. So with the aluminum in it, it had a volume of 13.5 milliliters, minus initially it only had 10.5. So when I subtract that, we get a volume of 3 milliliters for just the aluminum. Then I can plug into my density equation. That's 8.1, which is my mass, divided by 3, which we found to be the volume, and you get a density of 2.7 grams per milliliter. All right, in class, we're going to pause and we're just going to practice this a little bit, but for the sake of this video, we're just going to keep plugging through. So now that's our kind of overview of physical properties. Now we're going to talk about the other side of things, which are chemical properties. So these are properties that we can actually only observe and measure by changing the chemical identity of a substance. So just by observing it, we end up creating a new substance. So this is something like toxicity, flammability, combustibility, radioactivity, those kinds of things. So we're going to talk through a couple of these because these are ones that you may not be as familiar with. So first is combustibility. This is basically how easily does a substance set on fire. So for example, burning charcoal, burning paper, anything like that. Just by measuring how well it burns, you're burning it, and that's creating a chemical reaction that's actually changing the identity of the substance, which means it's a chemical property. Another is reactivity. How easily does the substance react with maybe different other different substances? Maybe an acid or a base. So for example, fluorine gas, it's highly reactive and it will spontaneously ignite a concrete block at room temperature, which is kind of crazy. Now, when it does that though, a chemical reaction occurs and we no longer have just the fluorine gas in the concrete block, thus making it a chemical property. Oxidation, how easily does a substance specifically react with oxygen? For example, iron reacts with oxygen and moisture and it creates rust. Something new has created rust. This is no longer the original iron. It's actually this new substance of rust, which makes it a chemical property. So when we're observing a chemical property, a change is occurring in the substance. And it's specifically a chemical change. But matter can undergo physical or chemical changes, so it's important you know the difference between those. A physical change is when I change a substance, but I'm only changing its physical properties. Like I take a piece of paper and I cut it in half, or I color on top of it, or I crumble it up into a ball. It's still paper. Or like an ice cube when I melt it. It's still water, it's just no longer a solid. These are ways that I'm physically changing it. Whereas a chemical change is a change in a substance that affects its chemical properties. And so a chemical reaction is actually occurring and making a new substance. So burning something rusting, something decomposing or rotting, those are all chemical changes that are occurring. And they're creating chemical reactions, which we're going to have a whole unit on chemical reactions to finish up our year. But a chemical reaction is a process by which the atoms of one or more substances get rearranged and they make something entirely new. So again, just a little tidbit because we're going to get into this more. But two things I want to mention about chemical changes and chemical reactions before we wrap up. One being the law of conservation of matter. This says that matter is neither created or destroyed during a chemical change. It only changes forms. So matter is not lost even when a chemical reaction happens. So for example, this little house of matches, it has a mass to it. When I burn it and it basically turns to ash, that there isn't matter that should be disappearing. There should be the matter may be changing forms. Some of it may have been released as a gas, some of it's converted to ash, but it's still, it should still all exist. It's not just disappearing. Last thing there's a couple of ways that we can identify if a chemical change has occurred and thus a chemical reaction's occurred. So we have a couple of signs of that. First, if you see a release of light, a sudden flash of light, that's usually the sign of a chemical change and a chemical reaction. A sudden temperature change, an odor change being given off. Think about when stuff in your trash can starts rotting. It just smells terrible because a chemical reaction's occurring. A sudden color change, like a flash of color. If a gas is given off, if it just starts bubbling. And also the sudden appearance of a solid. This is called a precipitate. So if you mix maybe two liquids together, liquid chemicals, then all of a sudden this powdery substance forms, that's a precipitate. And that's another sign that a chemical change and thus a chemical reaction has occurred. All right, so now we're going to practice this because it's really important that you can do density calculations and also that you can identify properties and changes as physical or chemical.